Okay, but how this Gradle ecosystem works in general, because I said that we are executing some tasks and so on. So let me show you some example of how tasks work by creating our own task. I ruined it. Okay, hello everyone. Nice to be in here. I love it here in Turin, and hopefully my talk will be a little bit in par with what Thomas said. So if what he was doing was too technical for you, I have no good news. It's gonna be technical as well. A lot of code coming in and a lot of Kotlin code as well. So yeah, not too much JavaScript for you today, I'm afraid. Anyway, let's start with some intro. It's me, my name is Michał, and this is how it's pronounced, Michał. And yeah, first of all, I'm a father, I'm a husband, but apart from that, I also do mobile development for 10 years, and I work for Software Machine for about 4 years. I did a little bit of Expo with Tomasz, and then I moved to agency projects. But you might be wondering, if we are not using JavaScript on my talk, then why are we even here? Why am I even here? Why? It's pretty obvious, because we all love React Native, don't we? But sometimes when we build our application, we don't only build JavaScript site. We need to build native application as well. And this is what sometimes happens. Yep. 23 seconds is quite like optimistic in this case, but the last one, get more help at help.gradle.org. Like, you didn't sign up for that. You wanted to write JavaScript, right? And what is this Gradle thing anyway? But you think, okay, it's only Android, right? It always is on Android. Like, Android doesn't work, iOS works perfectly, right? No, it doesn't. And then you see this, and what you want to do is basically this. But yeah, you wouldn't ruin this CRT monitor, would you? So let's start from the very beginning. First thing first, what is Gradle anyway? So how many of you is writing React Native bare applications without Expo Go? Pretty much half of the room. And how many of you use Gradle? Why someone dropped hand? Like, if you write React Native application without Expo Go, you do use Gradle, whether you want it or not, because it's the default build tool for all Android apps for 10 years or something like that. So pretty much when I started Android development. Yeah, it pretty much defines how your project is built in some build.gradle files. But it also serves as a dependency management, so kind of like npm/yarn, but at the same time nothing like that, because it has no log file. It does it totally differently, but we are not going into too much details on that. If you are interested, then grab me at the lunch break. And what's very important, not unlike package.json, its configuration files are just code, mostly or only exclusively Groovy or Kotlin code, depending on your choice. So what can we make of it? So let's take a look at your project. If you open your project in Android Studio, hopefully you don't do that, but if you do, you can see on your Project Explorer on the left pane this view, like with your project. This is some kind of open source project that we are working on. We can all see that. So there's this Gradle script thing that you are all scared of for a good reason. And if you expand that, you see a huge list of Gradle files. And the most important, actually, one is the most overlooked one, which is at the very bottom, and it is settings.gradle. So let's take a look at that. Under this path, in most of your project, you can see file that used to look in the past something like that. It's not like that anymore, because now React Native or Expo does most of the work for you in this file just by applying some scripts, but it's very good to explain how it actually does stuff under the hood to look at this old structure. So what it does, it, for example, defines some projects. Like for this instance, it includes React Native Web View, and it tells Gradle where to look for the code of this project. It also applies some custom scripts. In this case, this is the native modules.gradle, which does all those work for you nowadays. And it also includes your application project, which is the host for most of your native code in application, all those main activity, main application, the Java stuff that you sometimes need to fiddle with when integrating native libraries. And the way those projects, those modules are built is defined actually by build.gradle file. And when you look for build.gradle files within your projects, you get this. So which one are you actually interested in? Most of them are build gradles of native libraries you are using, but there are two that you should be aware of and that you should be looking and changing from time to time, because they are your responsibility. And those are the ones at the very bottom, those two build gradles, and we will go through them one after the other. So let's start with the bottom one at the list, but the top one in the directory hierarchy, which is android/build.gradle. So this file basically defines all the stuff that is unanimous for all of your projects. So what you want to look at is this ext block, which is extra or extension, I don't remember, block, which defines some properties that will be then shared along all your project and with other libraries, with your native libraries as well. And you can see that we already use code in here. So even though it looks kind of JSON-ish at the start, it actually is executable. So you can execute some code, do some ternary operators in here and stuff. Then there's this, just very briefly, these repositories, just so that you know, if you are in the top, in the root build Gradle, these repositories are repositories for your build scripts, not for your dependencies. And then there are some dependencies added to your build scripts, which you should take note of, because we will be referencing that in a minute. When you go to this next, this is the next part of this build Gradle file, those are the dependencies, those are the Maven repositories, the repositories for your native dependencies. So this is where Gradle would be looking for your Android libraries, like in this order. And you can also see that there is some code in here being executed to make it find some paths and stuff. And yeah, and now we will go to the other build Gradle that is your responsibility, and this is the one within your app directory. And it's much more important and probably much more relevant to your work, to your everyday work, but it's also huge. Yeah, it's just generated app generated from the template, and this file already has 240 lines of code, which is groovy code, so it's pretty much unreadable. But we will also look at some parts of it. So first lines are applying the plugins, and those are the plugins which are related to the class paths that I was showing you on this first. So basically, it is looking for those plugins in the repositories that are included in top level, declared in top level build Gradle. So if you are missing one of those plugins, if your Gradle shouts that he cannot find those plugins, then you should go to top level build Gradle and check whether it's all right in there. And thanks to applying those plugins, especially thanks to applying those com.facebook.react plugin, we can execute this React block, React function, which defines how React part of your application is being built. And this is all related to React Native, but there is also a part related to native application. This is this Android block, which defines your native Android application and how it's built, how it's installed, how it's handled then by Play Store, and so on and so forth. So let's focus on some key areas in here, because it's also quite huge blob. Very important one that will be relevant later in the presentation is this application ID. This is actually pretty much the same as bundle ID on iOS, if you are familiar with that. This is actually an ID that distinguishes your app from every other app on Play Store or on any phone. and we will be fiddling with that a little bit later. And very important also for you might be these build types, because you might have noticed that sometimes when you execute, for example, yarn Android or npm run Android, then you are installing app a little bit different than the app that lands on the Play Store then. This is because of those build types. When you are developing, you are running debug build type. When you are building for release, you are running this release build type. And yeah, we will also be talking about that in a minute. And let's go to the last very important piece of this file, which is dependencies. And this is the one that defines what native dependencies should be downloaded for you. And yeah, this is actually calling a function, which is an implementation, and it has some overloads, but it can take string as a parameter, for example, but you can also look at Gradle documentation and see that it's pretty powerful. It's not like just JSON that you can just write one script. You can, for example, exclude some part of the dependencies to download only some parts of them, you know, to keep your app small and to avoid some conflict and so on and so forth. But yeah, whew, that was a lot of groovy code, which is rubbish. Yeah, that was in Groovy, and we don't want Groovy. So it could be in Kotlin, and we saw some Kotlin already on Tomasz's presentation. So that's great, one less language to learn, right? But we would need to make some changes to our scripts, of course, apart from changing the name from build.gradle to build.gradle.kts, which is funny because it has like 2 extensions. We would need to make some major changes. There's pretty good documentation on that, but also keep in mind that it's not that easy to make those changes. Like, it's ambiguous in some places. But let me like highlight some key areas where those changes would need to be done, and to show you how similar those 2 languages look in this case. So this is how it looks in Groovy, and this is how it should look in Kotlin, like a little bit different. You have parentheses for calling functions. You have this plugins block, which wasn't present there in Groovy, but like in general, it looks similar. This is, for example, how you define a variable in Groovy, and this a string variable. So you see that you have this single quotation, for example, in Groovy, and this is how you do it in Kotlin. You have val keyword, which is for constants, but you can use var if you are changing that in the future. But other than that, pretty similar. Like, it's not Java, right, or C++. And yeah, there's also this part from app/build.gradle, which defines your application ID, which would look also a little bit different in Kotlin, because as you can see, like, there's some assignments look differently, and also like this accessing root project extras look a little bit different, but it's not that much. And the last part, which looks a little bit different, is how you define your build types. And this is actually the one that I like very much, because now you can see that this debug is something that is already there. Using named, we are referencing to build type that already exists. And if we want to create new one, we would call register, while in Groovy it's like looks the same. We don't know whether we are registering new one or using just the same one. So yeah, let's get another sip of water and get some shit done. See how can we leverage this knowledge to make something useful for us, something that we could use in everyday life. Not really, but maybe you will use your creativity. So let's get back to this particular, like, this is the part that is very important for me, because it defines how your application actually behaves, how it's installed and then distributed. So this is from app/build.gradle. So this lower level one, this default config that defines, for example, your application ID. And we can make use of the fact that this is actually an executable code, not package.json file like in npm or yarn. And we can add, for example, something like that to it. So we can use like environmental variables. Why not? And thanks to that, we can do for example, something like that. We can go to Android directory and use Gradle, not build with Yarn, but use Gradle wrapper script for that, and execute install debug task without any environment variable. But then, just after that, we can execute pretty similar command, but with app ID suffix environmental variable set to, for example, .second. And we execute this second time. What's the result? Result is like that. We have two same apps on the phone. Why would you need that, you might ask? Because, for example, you might have your application already published to the store, downloaded from the store, and you want to install second version just alongside this without uninstalling your application, your production application. And using this application ID suffix, of course, there are many other and better ways to handle that. You can talk with me on a break if you want, but this is just to showcase how powerful this can be. So we can have two versions of our applications installed alongside without the need to uninstall production version any time we want to work on our debug version. Okay, but how this Gradle ecosystem works in general, because I said that we are executing some task and so on. So let me show you some example of how tasks work by creating our own task. Custom task. So you saw that we were executing this command, gradle.app, and we were executing some different command, but if you execute this one, you can see all available tasks, Gradle tasks for your application. You can see that there will be some test tasks, some build, some install, something like that. Many of them. Very important for you will be this one, which installs the app on your phone, and this consists of two parts. First one is the module that is executed upon, so your application module, you usually want to use that, and the second one is actual Gradle task that is executed here. So this is this install debug task. And if we want to create our own task, we go to our build.gradle.kts. All the examples will be in Kotlin, but it looks pretty similar in Groovy. And we do something like that. So we register the task, we name it, then we do some configuration, and we have two lifecycle methods, one which is executed at the beginning, second that is executed at the end. We can have several of those, do first, do last blocks. And yeah, when we have this task registered, we can execute it typing something like that, .earn heroes, and we have something like that. But it's pretty useful, isn't it? Only this task, and it does print two numbers. So what's the reason for that? But just to show you how those tasks are being organized, because that might help you debugging if you came across some issues, we can declare that this task actually depends on some other task. So we can add it to the queue after install debug task. And this might come in handy. I don't know, you can report to your Slack channel that hey, I installed my app for 27th time this day. This could be very, very useful on your general channel, right? So yeah, now when you execute this command, you see that first it executed the install debug, and then after it executed earn heroes task. Also, you could do it you can invert this order by just changing depends on to finalized by, then the task will be executed in the second direction, but it was very tricky to get a screenshot of that because install debug logs a lot of stuff. But what if we wanted to add some task that will execute after install debug without the need to execute our task? So when someone executes install debug, for example, Yarn Android does that for you, we want to add some custom task without the need to changing the task that is being invoked. So we can do that. We can query all tasks and plug into when they are created, find the task that we are interested in. So in our case, install debug, and add a finalized block, add a task that will be executed after this install debug task will be executed. So the difference is that now, instead of executing rn heroes task, we execute install debug. So actually a lot of tooling does execute this task under the hood. And then now, after install debug, always our task will be executed. So we can also do some like additional stuff, like it's your creativity to do task, and this is how it's gonna look. Oof, we're halfway there. We are only one platform left, and we'll be good to go. Now, not really. We are much farther because there's not too much to talk. There's not that much power in Cocoapods as in Gradle, but we'll get to that. So let's get to the iOS. Let's start with the overview, just like with Android. So what are Cocoapods used for? So unlike Gradle, Cocoapods are only dependency manager for projects. So it has some similarities to npm/yarn. It's much closer. Like the distance from npm and yarn to Cocoapods is much closer than from npm and yarn to Gradle. Much. And it's configured mostly in Podfile and also in some podspecs. Like I will get to that in a moment. And it's also code, but in this case, it's in Ruby. So unfortunately, you need to learn another language to master that. So let's take a look at that. First and foremost, we need to look at Podfile, which is in your iOS directory. And this is how it looks. Once again, it's quite huge. Not as huge as this main build.gradle, but still, we will see some similarities with build.gradles or with settings Gradle, but of course it will look much more like Ruby code. So at the top, we were including or requiring some scripts, like auto-linking scripts and native pods scripts and so on, which will do most of the stuff for us. But also, I wanted to point out that even if in those files we are already making use of the fact that it's code, something that wouldn't be possible in package.json, we are actually reading some properties file and parsing it and then using those properties along the way. So it's pretty powerful. And thanks to applying those scripts and thanks to defining those properties, we can then execute something like that, which is actually setting up React Native for you. It's executing, and you use React Native method, passing them some arguments to figure out, to configure how a React Native application is being built for you on iOS side. And I said that this is pretty similar to Yarn because it has something like log file, but of course not Yarn log, but Podfile log instead. It looks something like that. And there's also second file, which looks something similar. Can you see the differences? Good, because they are the same picture. Those files should be the same. If they are not, then this is the clue for Cocoapods to say that, okay, you need to do pod install again, because it means that your local version of pods differs from the one expected in your Git repository. So this is, manifest log is not version controlled usually, while Podfile log is. So this is the way how to check whether your local version has the same dependencies as your version that you've downloaded from Git. And I said that apart from Podfile, there are those podspec files. So let's find them. And you can see that there are plenty of them. Again, even more than build.gradles, because there are 2 .podspec files per every library. It's like yoga.podspec and then yoga.podspec.json. Why is that? Don't worry, the second one you don't need to worry about, it just generated for you from this yoga podspec. Technically you could just create your JSON file without the need for yoga podspec, but why would you? If you can write a Ruby code rather than JSON, then like it's much more powerful. And this is how this podspec, one of those podspec looks like. So you can see that this is pretty similar to package.json in a way, because it defines some basic properties of your package, but it uses the fact that it's code, so it also parses some JSON, in this case, your package.json, and it defines like name and version similarly to package.json for your packages. And it also can define dependencies of the package. And in this case, this is like very simple example that it just defines that you need these dependencies, expo module score in this case. But it could be a little bit more complicated, like for example, like this one. So we can define what version do we need, and it's also a little bit more powerful than package.json, because those are the list of options that you can use, and you can find it in Podfile documentation very easily. Okay, so last part, custom tasks in iOS, similarly to Gradle, but well, no. There are no custom tasks in iOS because Cocoapods is not your build system. It's only dependency management. So if you want to build your custom tasks, so to speak, you are going to Xcode. And yeah, you don't want to go there, but you have to, because you have to find this build phases thing. And you can see that there are a lot of custom steps. Some of them are very React Native friendly, so to speak, like for example this one, start packager. And when we expand it, we can see that there is also some code, but this is, if Groovy is like ugly, then what is it? It's bash. So yeah, but usually the packages, how they do it, if they want to do something custom, they just write node script and execute it from bash, and that's how it's done. So yeah, the way around it. But anyway, like editing it is hell, and you can't really do it from VS Code easily, because like it's hidden somewhere in PBX Pro, I believe. So yeah, you usually don't want to do that too much. So that is pretty much it. I would love to speak much more about it, but I guess we don't have that much time, and I don't have slides for that. So anyway, now you have the power, and you can use it wisely, do some libraries, do some custom stuff, and follow me on Twitter. Thank you very much.